Okay, what's up? Start on the one sheet. So you got these two things and then the one packet where you have to draw the rainbows and crap. Okay, it amounts to 25 problems. So, number one, this is an item originally cost $40. It's marked 25% off. Remember, off means minus. So when I see a word that indicates plus or minus with a percent, I'm going to take the original times the percent equals the new. Oh, shoot, new. Okay, sorry about that. Okay, now I don't need to use an exponent because it doesn't say per. Okay, I don't see PER with my percent, so I don't need that power there. Okay, so the percent, we take 100% and we minus 25%. That's 75%, but don't forget to divide it by 100. So I divide 75 by 100, and that's 0.75. So that's your percent factor. Again, you don't need the power because it doesn't say per year or per anything. Okay, now read the sentence with the 40. It says original, okay? Put original there, okay? So $40 is the original, and to find the new, that's my x, okay? So the x is by itself. There's just the operation, multiplication with these two, okay? So I take 40 times 0.75, and that's 30. Remember, the label will match this label, so $30. Okay, number two, an item's marked 20% off. Again, off means minus. So minus with that percent means I want to take the original multiplied by the percent equals the new. And again, I do not need an exponent because it doesn't say per, P-E-R. I don't see that word with the percent. Okay, so I take 100% and it's off, so that'll be a minus, and it'll be minus 20%. That's 80%. Okay, divided by 100. 80 divided by 100 is 0.8, okay? So read the sentence with the 100, just from here to here. It says that's a new price. So 100 is the new, and X is the original. All right, so I can't multiply, so I need to connect the line and just put 0.8, because what I'm doing is dividing both sides by 0.8. So I'm just going to put a 0.8 under there. And I take X now equals 100 divided by 0.8. I've rewritten the equation. Okay, I got 125. So X is 125, and remember, if that's dollars, then it's going to be $125. Okay, number three, an item originally cost $50. It's marked 25% up, which means adding to it. Find the new price. So again, percents. Original times your percent equals the new. Okay, then I take 100%. Up means add 25%, and that's 125%. Now I divide by 100. So 125 divided by 100 takes it to 1.25, so that's my percent factor. Again, you don't have exponents on these because they don't say per. You're going to come across one later in this video where there is a per and you have to use an exponent. Okay, now read the sentence with the $50. An item originally cost $50, so $50 is my original, and then I'm left to find the new right there. And I easily find the new by just multiplying the original by the percentage. So 50 times 1.25, whoops, 50 times 1.25 is 62.5. Okay, that's okay. You can get a decimal because it's money. Okay, $62.50. Okay, now number four, an item's marked 30% off. Off again means minus. Its new price is $280. Find the original price. So I'm going with this slick little equation. So the original multiplied by your percentage equals your new. No exponent needed because it doesn't say per. Okay, so I take 100% minus 30%, and that takes me to 70%, and then divide 70 by 100. 70 divided by 100 is 0.7, so my percent factor is 0.7. Okay, now read the sentence with the 280. It says its new price is 280, so 280 is my new price, and I need to find the original price. Okay. All right, so again, to find the original, you can't multiply, so you have to connect this, and then 0.7 underneath, and then 0.7 there. And x now equals 280 divided by 0.7. So I divide 280 by 0.7, 400. X equals 400, so you can just put $400 right there. Okay. So we started at $400, 30% off. New price is $280. Makes sense if you read the equation through. Okay, now the back side, you got percents, but you don't have those words that indicate add or subtract. So I set up the problem different. It's a different type of percent problem. 20% of the people in town donated money to the senior class. If there are 300 people in town, how many people donated money to the senior class? So there's no words that would indicate add or subtract. So I set up my proportion with part whole. Okay, you always want to define your part, donated money. Part whole percent, usually the part did something that makes them special. Okay, so we use 100% in the denominator, and then we use 20% in the numerator. Okay, now 300 people, read that sentence. There are 300 people in town, but it doesn't say anything about them donating money, so that's not the part, it's the whole, and the x is the part. Then I cross multiply and divide 20 times 300 divided by 100. Don't forget to divide by 100. 60, okay? So it says 300 what? People, so you can put people on that. And I can easily see 60 people donated money. Okay, number 6, 40% of the students in school failed American history. That's not good. 80 students failed American history. How many students are in school? So this is another part whole. Because I don't, again, it's a part. What makes it a part whole is I don't see any words that indicate add or subtract. Okay, like you did on this side. Okay, so what makes the part special? Well, not really special. They failed American history. Okay, it's like the part that's shameful. Okay, all right, now 100%, take the percent from a problem, and it's 40. Okay. All right, now read about the 80. 80 students failed American history. So yeah, that's your part because it says failed American history. And what's it say about the 80 students? They failed American history. So it's 80 over x. Cross multiply and divide. So 100 multiplied by 80 divided by 40 is 200. Okay. So 80 students. So there are 200 students whole. Again, with percent problems with one unit, the label matches. Okay, number 7, 80% of the people in a town attend church. 700 people attend church. How many people are in the town? So again, no adding or subtracting indicators. So again, part whole. Now what defines a part? Well, those that attend church. Okay, what's it say about the, okay, sorry, set up your percent ratio. It's 80, because a percent is actually a ratio, it's over 100. Then what's it say about our 700 people? 700 people attend church. So it says attend church, so that's my part, and x is the whole. Okay, so I cross multiply and divide. 100 times 700, divide by 80, 875. Okay, so it's 700 people, so it'd be 875 people. You have 875 total whole people, 700 attend church, and that's 80%. Okay, number 8, 40% of the students in school eat school lunch. Remember percent. Okay, there are 250 students in school. How many students eat lunch? So 100%. Oh yeah, part whole. Okay, what does the part do? They eat the school lunch. Okay, so we have 40%. And what's it say about the 250 quantity? There are 250 students in school, but it doesn't say anything about them eating school lunch. So that can't be the part. It must be the whole then. Okay, so X. Then I cross multiply and divide. So 40 multiplied by 250 divided by 100 is 100. Okay. So it's 250 students. It'd be 100 students that eat the school lunch. You don't need to include that in the label. I can see that's the label, right? Students eat school lunch. Okay. Now, in the other packet, you got the exponents. The first page is a breeze. You just write out 2 7s and find their product. Don't take 7 times 2. 7 times 7 is 49. Remember, exponents mean multiply, but not multiplying the two numbers you have. Okay, negative 3 to the 6th power, so that's negative 3 as a repeated factor 6 times. $729. Positive product because you have an even number of negative factors. Okay, now here looks kind of the same, but here there's only 5 negative factors, so that's an odd. So I'm expecting I'll get a negative answer here. And I do negative 243. Okay, if you have a fraction with an exponent, it's not a big deal. You just write the fraction out 4 times. Multiplying fractions is really easy. Adding, subtracting is probably what when you think about middle school math and fractions, you're like, oh, I hated fractions. You probably hated the adding and subtracting them. Okay, multiplying them is easy. You just multiply the 2's. 16. And you multiply your 5's, 625. So 16 over 625 is the product there. Okay, so now on the back side, hold on, I don't have the boxes like you're supposed to have. Okay. Give me a second to get these down. You already have these, so. All right, now we can begin. Okay, first off, I want to make a dividing line, and I want to circle my parentheses. And there's a 4 outside, so any power out of here is multiplied by 4, but that's not in the parentheses, so you don't multiply 6 by anything. Okay, now if you look at all your bases, you have a number 4 and then the variable x. Number 4, letter x, put a times. Okay, now 4 is to the 1 power, but it's in the circle. So we have to multiply the 1 by 4, and that's 4. So 4 to the 4th power. Now the x, here's your first x. It's to the 2nd, but that's in the bubble, so we have to multiply 2 times 4, and that's 8. Now we do have another x here, and it's on top, so we add 6. We don't multiply 6 by anything. Now 8 plus 6 is 14, so we have x to the power of 14. Now circle your two factors. That's positive, so that's stay, and that power is positive, so that's stay. Okay, so they're both going to stay where they're at. So they're on the top, and they'll both stay on the top for the remainder of the problem. 4 to the 4th times x of 14. Now in the third box, what can I clone? Well, I can clone 4. 4 times 4 times 4 times 4. That's going to be what we put here. So 4 times 4 times 4 times 4 is 256. So I replace 4 to the 4th power with 256. And then you can't clone a variable, so that will remain x to the power of 14. It's cloning an x. I can't really do that on my calculator. Okay, now in our next problem, I underline the expression if I don't have a line already, and I circled what's in the parentheses. So anything out of there needs to be raised to the power of -3, okay? So I have a number 8, a letter x, and a letter y, okay? So 8's to the 1 power, but it's in the bubble, so 1 has to be multiplied by -3, okay? So 1 times -3 is -3. Okay, x to the 1. 1 times -3 is -3. And then y is to the 1, and that's just going to be -3 again. So now we have 3 factors. But all of them are negative, so they all go to the opposite. Okay, so that's on top, the opposite of top's bottom. 8 goes here, now 3 is positive. That's on top, goes on bottom. Now 3 is positive. That's on top, the opposite of the top's the bottom. 3 turns positive. That's why you make it opposite, because you don't like the negative exponent. Because I can't clone negatives, okay? So I need a way of dealing with those. Now, if the top is empty, you need to put the number 1 there, okay? So we'll put a 1 here. So which of those can I clone? I can clone the 8, so because it's a number. 8 times 8 times 8 is 512. Okay, so I replace that with 512, and then times x to the 3rd power times y to the 3rd power. That's it. Remember to put the 1 on top. Now, you don't need a 1 on bottom, but you do need it on top if you have nothing there to occupy it. Okay, now my next one. I actually have 2 separate dividing lines, which in multiplication I can just connect. And I do have a couple parentheses here and here. Okay, so on top of my dividing line, I have the number 4, the number 5, the letter A. So 4 times 5 times A. Now on bottom, we got the letter A, which I've already put there. But we also have the letter B, which I don't have on top, so I put it on bottom. A lot of people just put B on the top. No. If B is on bottom and that's the only place it is, then B goes on the bottom. Okay, so 4, remember, there's a 2 out there, so 1 times 2 is 2. Now let's go find our 5. That'd be to the 1. But that's in a bubble, because there's a 5 out there, and 1 times 5 is 5, so it's 5 to the 5th. Okay, now A, how many A's do you see? Right here and right here. So here's the first one. It's 2, but that's in a bubble. 2 times 5 is 10. Now my other A is on the bottom of the line, so that will be a minus, okay? And that's in the bubble still. So 3 has to be multiplied by 2, which is 6. And 10 minus 6 is 4, so it's a to the 4th. And then the B is to the 3rd. It's in the bubble, so we have to multiply 3 by 5 because the parentheses covers the whole thing. 3 times 5 is 15. So we have 4 factors. But they're all positives, so they will all stay. Okay, so since they all stay, that's on top, it stays on top. The 5's on top, it stays on top. The A's on top, it stays on top. The B's on bottom, it stays on the bottom. Okay, stay means don't move it. None of them go to the opposite side. Okay, now here are my factors again. I can clone a couple of them. 4 I can clone. 4 times 4 is 16. So I replace 4 to the 2nd power with a factor of 16. Now I know it's going to sound sucky, but you can clone 5 to the 5th. 5 times 5 times 5 times 5 times 5. Okay. 3,125, and I put it right where the 5 to the 5th used to be. Then the variables can't be cloned, so times a to the 4th on top and b to the 15th on bottom. Now look at these two. What operations between them? A multiplication. Well, I'm going to multiply these, okay? If it's division between them, don't do anything, but if it's multiplication, I want you to carry out the operation. That's 50,000, so just cross those out and just put the product 50,000. So that's the answer, 50,000 times a to the 4th divided by b to the 15th. Okay, and then this one is pretty annoying, okay? Now your dividing line's already there, but your parentheses only surrounds the 6x, okay, with a negative 3 outside. So anything in this little spot here is multiplied by negative 3. That, and that aren't in parentheses, so we're not going to multiply these. Okay, on top I got the number 6, the letter x, the letter y, and on bottom I got the letter x, which I already have written down from the top, and the y I already have. Okay, now it's go time. So 6 is to the 1, and that's in the bubble, so 1 times negative 3 is negative 3. Now the x, how many x's do we have? We have 2. Here's the first one. It's on top. It's to the 1 power, but it's in that circle, the bubble. So 1 times negative 3 is negative 3. Now the other x is on bottom, so that's going to be a minus operation of 6. Don't multiply the 6 because it's not in the bubble. Okay, so I go negative 3 minus 6. That's negative 9. So x is to the power of negative 9. Now y, how many y's do you see? You see 2. Well, this one's not in the bubble, so I just write that 3 down. And that's on bottom, so minus, and that's not in the bubble, the big bubble, so I just write negative 4 down. If you want to put a parentheses, if you have minus negative, I usually put the negative in parentheses. Then we're just going to calculate it. 3 minus negative 7. Now, what does that really mean? Well, it means 3 plus minus negative 4. What's that really mean? It means 3 plus 4. What basic math terms, what's 3 plus 4? I'm guessing 7. Okay. All right, 3 factors. I got to decide what to do with them now. That's negative. That goes to the opposite. That's negative. That goes to the opposite side. That's positive. That stays. So 6 is opposite. What's the opposite of top? Bottom. And 3 turns positive. That's on top. What's the opposite of top? Bottom. 9 goes positive. That stays. Well, it's on top. It stays on top. Okay, and then which of these buggers can I clone? I can clone the 6, okay? You can't clone the y. That's a variable, so that stays put. 6 times 6 is 216, okay? So replace that with 216. And then the x to the 9th can't be cloned. So that was a little bit harder than I'm used to. Okay, scientific notation. Now remember, it's something times 10, and we need a power on the 10. Now here's my decimal. Now looking this way, what's the first number I have that's not 0? That's 0. 0, 0, 0, 0, 0, 0, 8. So I want the decimal to go between the 8 and the 0. So I'm going to mark where the first non-zero number. Decimal's got to be moved between that number and the number after it. Well, that would mean I'd move it this way. That's right. Right is a negative exponent. Okay, so I put negative, and now I move it between the 8 and 0. So 1, 2, 3, 4, 5, 6, 7. Okay, so now I have my decimal with 8 in front, 0, 9 behind it. And my power is between the digits, 1, 2, 3, 4, 5, 6, 7. So 10 to the negative 7th power. If you're not sure, punch it into your calculator, and it should 8.09 times 10 to the power of negative 7. And that looks exactly like what I started with. So that's right. Now on the next one, got a little problem. I don't see the first decimal, so it's at the end. Now find your first number this way that's not 0, not this way, this way. Well, right away I have a 3, so that'll work. So it goes between the 3 and the 8, okay? To get there, I need to move the decimal this way, and that's left. Left will mean a positive exponent. It's the opposite of a number line. So move it. Count as you're moving it. 3, 4, 5, 6, 7, 8, 9, 10. So I got point and then 3, 8. Now there's 10 digits between decimals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 to the 10th, and it's positive, okay? Not negative like here, because again, if you don't believe that that works, take 3.8 times 10, hit your power key, the caret button, 10. Okay, that crap's not, yeah, forget that. Okay, now these are easy. Now it's in scientific. You got to find the number that it actually is. So 7.3 times 10, hit your caret button, 8, write out the number. So 7.3, and then you got 7 zeros behind it. There's no decimal, so I put commas, 730 million. In this one, I take 7.2 times 10 to the power of negative 5. And it's a really small number, so 0.00072. Usually the positive powers end up as big numbers, the negatives end up as really tiny decimal numbers. Okay, now, your computer cost $2,600 originally. The value of the computer decreases by about 15% per year. Find the value of the computer after 4 years. Now this time I have 2 units, dollars and years. So I make my first box because I have highlighted the units. You need to examine them. The independent variables, years, that's X, and then Y is money. So per year. Per year. It'd be dollars per year. Well, the only thing I see about per year is the percentage, 15%. Okay. All right, so since we have a percentage, we don't make a graph like with the line. We go blank times blank equals blank. So original percent and new. Okay, now since it's per year, you need an exponent, okay? So my percent, I take 100%, and it decreases, it means subtract, so minus 15%, and that's 85%. Divide by 100. It's the same way I do those other problems. There's just a power of the years. So I divide 85 by 100, and that makes my percent factor 0.85. Okay, now $2,600 is the original. I marked that. And we need a power. Now remember, it said per year. Well, how many years do I have? 4. Okay. So that's going to be my power. Okay. And I just multiply. So 2,600 multiplied by 0.85 to the power of 4 gives me 1,357. Since it's a money amount, I want to take the first 2 digits after the decimal, either 21 or 22. So $1,357 in either 21 or 22 cents. Okay, then the final problem. The population in Austin, Texas was 494,290 people. The population increases by 3% per year. Find Austin's population 10 years from now. So we've highlighted a couple units, people, and years. So that means that forms a rate of change. Okay? Years is X. The time's always X. Then per year, and then we put people above it. Now, there is no people per year. It's a percentage, okay? 3%. So with that percentage, I don't make a line. I only make a line if that would have been people, but it's percent. So that means I set up the original times percent is new. And we need a power because the percent occurs per year. So original, percent, and new. Okay, so the percent, we take 100%, increase by 3. So that would mean add 3, and that's 103%. Now again, you have to divide that by 100. You don't want to just put 103. Okay, 1.03 is what I came up with. And this is my original, 494,290. Okay, now we need an exponent because it says per year. Well, how many years we got? We got 10, okay? So it's to the 10th power, and x is the new. So 494,290. And some of you might be wondering, why is it an exponent instead of just times 10? Well, I've already used times right here, okay? So to repeat multiplication, times is repeated when I've already used addition here. Well, if I've already used multiplication, we need an exponent to repeat what's happening. Times 1.03 to the power of 10. And this is people here. That says people. You can't really see it. So I don't need people. I don't have decimals, okay? I put 664,284. That's how many people we have.